Hello, hi, good morning. Yesterday we did determinants. Actually, day before yesterday we started with determinants. Um, and we have already done minors. Cofactors I started, but today I'll give more questions on that. Let me start. Topic is determinant. Subtopic is minor. Whenever we have to find minors. Later on, I'll find cofactors also. So I'm taking one question and then we'll do. Matrix is 1, 2, 3. 1, 2, 3. 4 minus 5, 6, 7, 0 minus 1. Okay. Now what we have to find, see how many elements are there first. A11, first row, second column, first row, third column. That means A11 is there, A12 is there, A13 is there. Okay. Similarly, A21, A22, A23 is also there. Similarly, this is third row, first column, third row, second column, third row, third column. Okay. So M11, M12, M13, M21, M22, because whatever the elements are there, its minor is also there. Okay. So M22, M23, M31, M32, M33. Okay, these things we have to find. How we have to find that I'll tell you. All right. Now, M11 means first row, first column element. This is first row, first column. Leave them. Which numbers are left? Minus 5, 6, 0 and minus 1. These four numbers are left. We will find its determinant. Minus 5, 6, 0 and minus. Now what it will be? Diagonally multiply and subtract. Minus 5 ones are, minus minus, it will become positive. 6 zeros are 0. So answer is nothing but 5. This is my M11. Now we'll talk about M12. M12. That means first row, second column. Leave them. Which numbers are left? 4, 6, 7 minus 1. 4, 6, 7 and minus 1. These numbers were left. Find its determinant. 4 minus 1s, minus 4. Minus sign. 6 sevens are 42. So it will come out to be minus of 46. Next, M13. First row, third column. Leave them. Which four numbers are left? 4 minus 5, 7, 0. 4 minus 5, 7 and 0. 4 zeros 0 and 7 minus 5 are minus 35. Minus minus it will become plus. Similarly, we'll go for M21. 21 means second row, first column. Which 4 numbers are left? 2, 3, 0, minus 1. 2, 3, 0, minus 1. Find its determinant. 2 minus 1's minus 2. 0 3's are 0. So it will come out to be minus. M22. M22 means second row, second column. Leave them. Which numbers are left? 1, 3, 7 minus 1. Diagonally multiply and subtract. It will come out to be minus 22. M23. 23 means second row, third column. Which 4 numbers are left? 1, 2, 7, 0. Diagonally multiply and subtract. Now we'll start with M31. M31 means third row, first column. Leave them. Which 4 numbers are left? 2, 3 minus 5, 6. 2, 3 minus 5 and 6. 2, 6 are 12. 5 minus 3, 3 minus 5 is minus 15. Minus minus plus. It will come out to be 27. M32. 32 means third row, second column. Which 4 numbers are left? 1, 3, 4, 6. Diagonally multiply and minus. M33. Third row, third column. Which 4 numbers are left? 1, 2, 4 minus 5. It will come out to be minus 5, minus 8. It will become minus 30. Note it. So the thing is, whatever he is asking, 1, 1, 1, 2, that row and that column you have to leave. If only one number is left, that is the minor. If 4 numbers are left, then find its determinant. Note it quickly. Next topic is cofactors. Cofactors is related to minors only. Just one formula is there. Actually, Only sign will be different in few cases, otherwise numerically value will remain same also. How, that also I'll tell you. Okay. Next thing is cofactors. Cofactors, in few books you will see it is represented with capital A, or few big books it will be represented with capital C. In your material it is associated with capital C only, so I am writing it capital C, but somewhere you will see capital A also. So now Cij, that means cofactor of ith row and jth column, is nothing but minus 1 raised to power I plus j, whatever the numbers are here, I and j, that will be added at the as a power, and m of ij. Okay. Till now we have find the values that I am going to write over here: m13, m21, m22, m23, m31, m32, m33. These are the values we already have found in the last question. 5 minus 46 and 35, minus 46 and 35, m21 minus 2 minus 24 minus 14, this we have already found. 27 minus 6 and minus 30. These are the values we have already found. Now when minors are already there with us, it's very easy to apply the formula now. Now what I am doing? Minor 1 1, cofactor 1 1. Cofactor 1 1 means what? Minus 1 raised to power. These two numbers will be added, 1 and 1. Okay. And m of 1 1. Now minus 1 raised to power 2 is nothing but what? Even power. Even power, it will become positive. And m11 as it is. So it will come out to be 5 only. How? That I'll again write it. Minus 1 raised to power square into 5, it will come out to be 5 only. Next step, C12. Now I am finding the cofactor of first row and second column. Apply the formula, minus 1, these two numbers will be added, 1 plus 2, and m12 as it is. Minus 1 raised to power cube is nothing but minus 1. m12 is nothing but already we have minus 46. Minus minus plus, and 46 ones are 40. Similarly, we will find C13 minus 1 raised to power 1 plus 3 into m13. Now it will come out to be 4, even power, so it will come out to be plus, and it is nothing but already 35. 35 ones are 30. Anyhow, see, these are numerically it is same, 5 and 5. But 46, sorry, minus 46 and 46. Alternatively sign will get changed, because alternatively power is getting even, odd, that's why it is getting. C21 minus 1 raised to power 2 plus 1, m21 Again it is 3. Power is 3. Odd, it will give -1 only. M21 is -2. -1 and -2 is nothing but positive. C22, it will become positive. M22 is -22, so -22 as. Similarly, C23, -1 raised to 2 plus 3, M23, it will come out to be -1 because odd power, and -14, minus minus plus. C31, -1 raised to 3 plus 1, M31. Power is 4. Power is even. When power is even, it will become positive 1. M31 is 27 only. 1 into 27, 27. C32, -1 raised to 3 plus 2, and M32. What it will become? Power 5. Power 5 nothing but odd. Odd means power it will give the result as -1. M32 is nothing but -6. Minus minus plus. C33, -1 raised to 3 plus 3, M33. Power is even now. It will become +1. M33 means it is already given to us as -13. When you will multiply them, it will come out to be -30. Note it. I hope it is clear. Just apply the formula and get the value. That's it. Quickly note it. After this, I'm going to tell you adjoint. See, this is the concept. When we'll do more questions, again these concepts will be applied there and will be revised also side by side. One thing I want to tell you is, see, understanding the concept is one thing, okay, but application of the concepts is different thing. If teacher is teaching, of course you will understand, okay, step by step she is teaching, she or he is teaching, and you will understand. But if you will not practice, you will not be able to retain it for the longer period of time. That means if you have to retain the concept in the mind, you have to practice, handwritten notes should be there first, and then you have to do the handwritten practice also. That is very, 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 very mandatory. If you are understanding the concept, okay, but you will not be able to retain it for longer period of time if you will not practice. Okay, you have done this concept also, this concept also, this concept also, but after 1 year or 2 years, you will not remember. So for remembering, or remembering is okay, one part, okay, for remembering also you have to do the handwritten practice, And if you don't know the first step, like what to write, how to write, then how you'll be able to understand, okay, which concept shall I apply here to get the answer? That application should also be there, no? That application also comes through handwritten practice only. So handwritten practice is must, must, and must. Next, now we have found the cofactors. Cofactors are nothing but what? Cofactor of first row, first column, first row, second column, first row, third column. 2 1, 2 2, 2 3, 3 1, 3 2, 3 3. Okay. Now with this, I am going to tell you a new concept, that is adjoint of A. This is nothing but we call adjoint of A. Now what does it mean? Whatever the cofactor matrix you have got, which matrix you have, a C11 value is 5, 46, C13 value is 35, 2 minus 2, 2 minus 22, 14. C31 27, 6 minus 13. Okay, this matrix we have got. This is the cofactor matrix. But now we'll take the transpose of this cofactor matrix. That means definition of adjoint of A is nothing but whatever the cofactors matrix you have got. Cofactors matrix you have got, take the transpose of it. That is the definition of adjoint. Whatever the cofactor matrix you have got, take the transpose of it. Transpose means what? First row will become first column. Second row will become second column. And third row will become third column. So this is my adjoint of A. I hope this is clear to all. First we have found minus, then we have found cofactors, then we found cofactors matrix, then we found its transpose. Means to find adjoint. See, right now you are seeing, oh, so many steps. No, when you will do so much practice, no. So these steps you guys can skip, no. Why to write all these steps? Simply write 5 minus 46 and 35. These calculations you can do it in the minds also. No problem. Okay, here you can skip the calculations. Then why to unnecessarily write all these steps? Simply minus 1 square will come. We know which thing is going to come. Okay, so many right now. So I was explaining to you. I can't explain verbally only, no, everything. If I will explain, okay, I will explain, but you will not understand then if I will not write more. So, so many steps are there, but when you will be through with the practice, you have a strong command over the concept, you have done so many questions, so many things you have done, then you can skip few steps, no problem at all. But it depends where you are writing. Like if you are writing for your boards, okay, then so of course you have to write the steps. No? But that also we will tell which steps, okay, particular teachers will tell you in which subject, how much you have to write. Those things also proper guidance you will get. No issues. And then you have to find the adjoint. Adjoint, how you will find the cofactors, take its transpose and get the adjoint matrix. Alright, now I'm going to write few properties. You have not written. I hope all of you have written this. Write it quickly. Write it quickly so that I can start with the properties also. Properties of adjoint. So today we have done 3 topics: minors, cofactors and adjoint. Alright. Next slide. If anything is left, if you are not able to complete the notes, of course you have to see the video once again and you have to complete your, because here I can't spend more time on writing part, no? Explaining part, if it is done, then that so you can rewrite, I mean you can write it when you see the video once again. Next, properties. Before that, one thing I'm telling you, singular matrix. What do you mean by the meaning of singular matrix? If any matrix is given and its determinant is coming out to be 0, that matrix is known as singular matrix. Any matrix, if its determinant is coming out to be 0, determinant means that fully solved we have and the answer is coming out to be 0, then we will say that matrix is singular matrix. And if determinant of A is non-zero, we will say it is a non-singular matrix. Simple. Okay. All right. Now properties. First property, A into adjoint of A matrix. Any matrix, whenever you will multiply with its adjoint. Always it will come out to be the determinant of A is there as a common or scalar number, you will say, into identity matrix, and of course identity matrix of order n. Either you write A into adjoint of A, or you write adjoint of A into, they are commutative. Note it. Second property, determinant of adjoint of A. Determinant of adjoint of A is nothing but whatever the determinant is there for A, it will become the power as n minus 1. Power will become n minus 1, where n is the order of matrix A. N is order of matrix A. Third thing, adjoint of A is one matrix. No, adjoint of A is one matrix. If I talk about again adjoint, okay, what it will come? This is determinant, a scalar value. This is a matrix. It will come out to be a matrix where determinant of A raised to power n minus 2 into the matrix A. These properties I'll explain you also with the help of examples. No issue. Fourth property. Now we'll talk about its determinant also. It will come out to be related to determinant of A. Determinant of adjoint of A now I'm talking about. See, this is a matrix because scalar is getting multiplied with scalar. Oh, so scalar is getting multiplied with matrix. So in the end it will come out to be a matrix only. Okay. Now of a matrix we can find its determinant. When you will find the determinant, it will come out to be determinant of A whole to the power n minus 1 whole square. Determinant of A n minus 1 to the power square. Note it. Next, see whatever the behavior of A is there. Behavior means if A is singular matrix, if A is non-singular matrix, if A is skew-symmetric matrix, if A is symmetric matrix, this kind of behavior I am talking about, or nature I am talking about, it will have some effect over its adjoint matrix also. Now, what I am saying is, suppose if A is symmetric matrix, symmetric matrix, this implies adjoint of A matrix is also symmetric. I'll give the examples. This I am bifurcating into 4 parts. If A is singular, adjoint of A is also singular. Next, if A is non-singular, adjoint of A is also non-singular. Okay? If A is invertible, invertible means inverse exists. Inverse means that we'll do the next topic is inverse only. If A is invertible, then adjoint of A is also invertible. Note it down. So it depends upon A. If A is symmetric, adjoint of A is also symmetric. If A is singular, adjoint of A is also singular. If A is non-singular, adjoint of A is also non-singular. If A is invertible, adjoint of A is also invertible. So these are the 4 behaviors we are talking about, and if the time will allow me, I'll give you the examples also. Otherwise, next. 1 or 2 questions I'm going to do now. 1 or 2 questions I'm taking now. Done? One question I'm taking, suppose find the determinant of any matrix I'm taking 1 to 4, 1 to 4. These 2 elements I'm taking as 0, 0, minus 1 and 3, 4. It is not necessary that I should take any book example only, but randomly I have taken. Why I have taken, my main aim is to tell you whenever any row and any column is having zeros, expand through that only. Now what does it mean? Column 3 is having 2 zeros, expand through that. Now how? This is plus sign, this is minus sign, this is plus sign. Yes? So plus 4 as it is. Plus 4 lies where? This row, this column. Leave them. Which 4 numbers are left? Minus 1, 3, 4 and 1. Minus 1 and 3, 4 and 1. Okay? If this is plus, this will be minus, this will be plus. Then it will become what? Minus 0 plus of 0. No need, no. 0 and multiplied by anything will come out to be 0. 0 multiplied with anything will come out to be 0. So that's why try to have maximum number of zeros, maximum means 2 zeros, so that you can expand through particular row and particular column. Anyhow, answer will come out to be the same only. How? If you will expand through first row also, no, that we have already done that kind of questions, then also answer will come out to be the same only. Plus 4 means 4 only. Multiply. This will become minus 1. 4 3s are 12. So it will come out to be 4 into minus 13. Yes. So it will come out to be 52 with minus 7. Yes. Now 0 terms as it is, I'm not writing because anyhow answer will come out to be 2. Now suppose if I'll expand this I have already expanded through expand by column 3. Now I'm expand by column row 1 only, or answer will come out to the same only. See, 1 lies in this row, this column, leave them. Which numbers are left? 3 0 1 0. 3 0 1 0. Minus 2 now. Minus 2 lies first row, second column. Which numbers are left? Minus 1 0, 4 and 0. Plus 4. Which numbers are left? Minus 1 3, 4 and 1. Now if you will multiply 3 into zeros, 0. 0 into 1, 0. So 1 into 0 minus 0. Minus 2, 0, and this will also become 0. So plus 4, this will become minus 1, this will become minus 12. Anyhow, these terms will come out to be 0. This will become 4 into minus 13. Answer will come out to be minus 52. Answer will come out to be the same. Either expand by column 1, column 2, or column 3, or row 1, row 2, or row 3. So try to expand wherever maximum number of zeros are there. That's why I first started with column 3. One more question. Alright, first I'm just recapitulating what I've done, then I'll do the question. See, first today I started with minors. How to find the minors? If I'm talking about particular number, leave that particular row, leave that particular column. 4 numbers will be left, take its determinant. This was the slide for minors, how to find the minors. I hope there is no doubt. This will, like when you will write your exams, no, then it will be very much helpful for you people. Then we found cofactors. Cofactors, this formula is the simple, the basic formula only. One formula is there. Minors are already there with us. Apply that formula. Here if it is I and j raised to power, it will become I plus j. Then we'll apply this formula. We'll get the cofactors also. In few books, they will write A11 In few books they will write C1. Okay. Tomorrow I'll tell you one more formula how to find the determinant. Okay, or determinant can be written as in terms of cofactors also, that also I'll tell. System also I can tell, but let me complete this. Cofactors matrix, first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first column, third row, second column, third row, third. Okay. When we'll do its transpose. Transpose means first row will become first column, second row will become second column, third row will become third column. That matrix will come out to be the adjoint of it. Okay. And then we did few properties. These are very important. Sometimes directly question comes like for this also, for this also. These all are important ones. That's why I've written on board. All are important. Direct question comes. So, or this concept will be applicable somewhere. Then we have next properties. If A is symmetric, A is singular, A is non-singular, A is invertible. Respectively, few things will happen with the adjoint of A also. And then we did this question, find the data. So tomorrow what I'll do is, I'll do so many questions on the basis of cofactors, minors, and inverse. Inverse topic is very important, and one more topic is going to come very soon. It will come. That topic is system of linear equations. Okay, that Cramer's rule will be there. So that will explain, and of course that question is important one. Okay, so we'll meet tomorrow, same time. Bye guys. I hope you have understood everything. Just see the video once again so that whatever the things you have not understood, you can again